Boring. So look here, what you have, 560 divided by 1.6, right? So just do the calculation for this part. 560 divided by 1.6. What is the answer? Hello, Mahi, Mahi.
Yes, sir.
560 divided by 1.6 into 10 to the power minus 19. You got it, right?
Yes, sir.
So when you are doing the calculation, you should give your, if you are writing 10 to the power minus 19 in your calculator, you should give your bracket. Okay. Before 1.6, give a bracket, and after 10 to the power minus 19, bracket close. Then you check what is your answer coming.
Okay, sir.
Otherwise, it will come wrong. That's why your answer came minus 17, but it should be uh, plus. The power should be plus. Have you got it?
Yes, sir.
What it
Sir,
came
it's
now?
3 point. So it's 3.5 times 10 to the power 21.
10 to the power
21.
21. So the same thing, only for changing the writing style, it came now correctly. Previously, it was wrong, right?
Yes, sir.
So what you said, I'm writing is question number, and later I will show you how you can do it even without power. That will make your life easier. So not only for this question, for many other questions, we'll get very simply the answer. 3.5 into 10 to the power 21. Yeah, 5 into 10 to the power
Sir,
20.
let my she's in the waiting room.
Who is that?
Maimuna. Sir,
Maimuna,
I'm
I
Mariam.
I I accepted her.
Oh,
I
okay.
accepted her. She came, right? Oh,
No,
she.
her phone is still showing she's in the
Oh,
waiting room.
oh, oh, oh.
She's joining.
Yeah, now she's joining. Okay. So 3.5 into 10 to the power 10. Now, what is the simplest technique? You see, if you only do the calculation with this part, you forget about this power. Just only this part. 560 divided by 1.6. What it comes? Check. Mahe. 560 divided by 1.6. Only this part. Hello, Mahe is there?
Sir.
Hmm.
Sir, 560 divided by.
1.6. Simply you write this 560 divided by 1.6. How much it is?
So it's 350.
350. Okay. 350. That means you can write uh, 3.5 into 10 square, right?
Yes, sir.
And here we have 10 to the power minus 19. 1 divided by 10 to the power minus 19 means 10 to the power 19, right?
Yes, sir.
So 10 to the power 19 and 10 square, it comes together 10 to the power 21. Got it?
Yes, sir.
So without writing the power even in the calculator, you can do it. Okay. Only you
Okay, sir.
are doing the numericals, what is available here. Then the other things, it will come by simple calculation in your brain. So this way you can do. Okay. This is very simple. Some of the questions, in your AS or A2, you will get more, complex, bigger, larger calculations with many other powers. Maybe at the top there will be 10 to the power 10, and then 10 to the power 11, and 10 to the power 17, and 10 to the power minus 18. This way, lots of power will come. Then you can calculate them simply with this power. Power can be added or subtracted, right? The way we added
Yes,
19
sir.
and 2, right? Uh,
Yes, sir.
Simply we can do that other than writing on the calculator. So these are called index form, right? The power. Sometimes it is called standard form or index form. So everyone is done. You understood it?
Yes,
This
sir.
part. What about others? You have any questions here? You understood everything? Farabi, Lamisa, Adrita, Maria, Maimuna?
Yes, sir.
Okay, thank you. Now I'm taking the snapshot. Step A. Are you so busy, all of you? Hello?
No,
All right.
sir.
But I'm not getting the works from you. It seems that you are too much busy still. Like the notes on static electricity, still I did not get from you. Many of you did not submit the worksheet on topic 17, magnetism, electromagnetism. So already we are almost at the end of the worksheet of topic 18. So we should get the all the pendings, right? As soon as possible. Today is
Yes,
22.
sir.
22. So now this one, huh? Calculate the average current in the lightning strike. For this one, the formula required you don't know. That one I'm giving you. The formula of current is current equals charge divided by time. This formula you'll get in next topic, topic 19. It happens in Cambridge that sometimes they are mixing up questions. During the final exam, you are almost You are done with all the topics. That's why they give mixture questions. In bigger questions, they give like two, three topics together. They make the questions. That's why we got this part. So it is very simple formula. Current equals charge over time. You know the charge, right? And the time is given also over there. You have the worksheet printed. You can check it. What is the value of charge? The charge is given how much? Huh? What is the value of charge given? 560, right? Hello? Hello? Are you listening, everyone?
Sir,
Hello?
your voice is cracking.
Oh, my voice is not going clearly. Okay. So my uh, as my voice is cracking, I don't know you heard how much. I was saying about this formula. Have you got this formula? Current equals charge by time. Hello? Did you get the formula? Hello? Amrita?
No, not yet.
The formula I gave you. Current equals charge over time. This one. Calculate the average current in the lightning strike. This is formula, right? Required formula. Hello, are you listening now clearly?
Yes, sir.
Farabi, Lamisa, Mahi,
Yes, sir.
Mariam,
Yes, sir.
are you listening now?
Yes,
Okay,
sir.
okay. The formula required, you saw, right? Current equals charge over time. Hello,
Yes, sir.
and charge is given how much in the question? 560 coulomb, right?
Yes, sir.
Yes,
Yeah, and time is given how much? Time is given 2 into 10 to the power minus 4, right? Very small time.
Yes, sir.
So now you can calculate the current. It's very a big current, large current. Calculate 560 coulomb divided by how much? What is the time?
Sir, 2.0 times 10 to the power minus 4.
Yeah, 2.0 times 10 to the power minus 4. Minus 4 we are writing here. This second, right? Coulomb per second, huh? So 560 divided by 2 into 10 to the minus 4. Now you calculate like before. Do the calculation and tell me the answer quickly.
sir. 2800,000.
So in power, what can we write in standard form? In two
Sir,
significant
2.8
figure,
into 10 to the power.
2.8, right? So you write here 2.8 multiplied 10 to the power 6,
Yes, sir. 6.
10 to the power 6. And the unit will be coulomb per second. You can write also ampere, huh? Or ampere, huh? The unit of current is also known as ampere. Okay, you can write coulomb per second or ampere. Ampere, in short, we can write as A, ampere. So now Farabi, Lamisa, Adrita, Mariam, Maimuna, have you understood?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
And you practice it gradually. You will be familiar with this standard form. Okay. And it's better to write in standard form other than writing so many zeros. You write in index form or standard form. That's making your calculation easier, right? Now we are going to next. Yeah, Adrita, can you read? Continue.
Two flat metal plates are positioned horizontally, one above the other. Figure 4.2 shows the positive terminal of a high voltage supply unit connected to the bottom plate and the negative terminal connected to the top plate. The high voltage supply is switched on. Number 1, on figure 4.2, draw the shape and the direction of the electric field produced.
Okay. So you know, right, how to draw the plate. If there are two plates, parallel plates, then how the electric field is working over there. Electric field lines. We showed you, right?
Yes, sir.
So how it will be? It will be from positive to negative or negative to positive?
Positive to negative.
Positive to negative. So you draw some lines, parallel lines from positive to negative with arrow. Huh? It's appreciated if you draw at least four vertical lines between plates, and all the lines are spaced equally spaced, right? And at the end, the lines will be curved, right? Isn't it?
Yes, sir.
And we showed you the diagram before. We get the lines from positive to negative by arrow, right? We will show
Yes, sir.
arrow. So do it, please, everyone. We have some lines like 1, 2, 3, 4. They should be equally spaced, right? Here, the space between them, it will be equal. Then we should show arrow here to here. We should arrow. This way you should show arrow, huh? Then at the end you show two lines. Those will be carved little bit, huh? Little bit carved, huh? More far, more carved. Here you show little bit carved, huh? And we show the arrow direction also here. Okay, this way it works. Got it, everyone?
Yes,
Hello.
sir.
Yeah, we're done with this part. Finish drawing.
Yes, sir. Done.
Thinking. Now next part. Yeah. Yeah. Now next part. It's very nice question because you have to use your thinking capacity, thinking ability here. So you read here, Adrita, read and try to get the answer.
Number two, suggest why a small charged oil droplet placed between the two metal plates accelerates upwards.
Mhm. So if you are placing any charged droplet, like they are saying oil droplet, so it's more likely that it should go down, right, due to gravity, isn't it?
Yes.
If there is any oil droplet or any object, it must have some gravity, right? Gravitational force working downwards. Whatever the size is, it should have some mass, and due to that mass, it should have some weight or gravitational force working downwards, isn't it?
Yes, sir.
That's why it's likely to go downwards. But they are saying it's going upwards. Why? Why it's going upwards? Or when it should go upwards?
The
Any
oil
idea?
droplet is a charged particle. Yes, sir.
Sorry?
I have one. I was saying that the oil particle droplet, it's charged particle, and it's inside an electrical field, so it will follow the direction of the field, and therefore it will go towards the negative plate.
Okay. Thank you so much. Any other idea from anyone? Mahi, Lamisa, Mariam, Maimuna, Arabi?
Yes, sir.
Any idea like why it's moving upwards? There is given negative, right? This plate is connected to negative, right? That's why this plate is negative. Negative means what? There is electrons, right?
Yes, sir.
And when something is attracted to negative, that means that one is positive, right?
Yes, sir.
So here in the lower part we have positive, and the upper part it is negative. So if the charge well droplet it is positively charged, then it is possible that it's moving upwards, right? Isn't it?
Yes.
Because it is repelled by positive and attracted by negative. This is first thing. And another thing is, uh, we have a gravitational force working downwards. However, there is electrostatic force also working there. Electro Electrostatic, repulsing, and attracting force, right? Hello, on the charge droplet, right?
Sir.
So here gravitational force, whatever it is working, that is working downwards. Electrostatic force is working upwards. Now, as it is going upwards, it said it's accelerate upwards. That's why we can say the resultant force is working upwards. That means resultant means what? Resultant means the sum of the two forces, that is working downwards and upwards. If you make the sum, the resultant is working upwards. Like, I'm giving you a very simple example. Like the gravitational force, maybe it is only 2 Newton. Okay, just for example, it is very small. As it is charged droplet, it should be very small. For example, it is 2 Newton working downwards, and electrostatic force it is much more stronger. Maybe it is working upwards, that is 5 Newton. So 5 Newton is working upwards and 2 Newton working downwards. So what is the resultant? Resultant is how
3
much?
newtons.
3 Newton, and that 3 Newton is
3
working, yeah, 3 Newton is working upwards. That is called resultant force. So the resultant force is working upwards. That's why the charge droplet is working upwards. Is it clear? Hello?
Yes, sir.
Okay. So how can we write all these 3 points? We are organizing the points here. First point, you got charged droplet is working, is likely to be positively charged as it is accelerating upwards, right? So,
Yes, sir.
so the first point we should write here, that the charge droplet is positively charged. That's why it is accelerating upwards. Why? Because unlike charges attract, attract, like charges repel. This is another point. Then third point you write electrostatic force is greater than gravitational force. Okay, we join after 5 minutes.